This is the prototype instrument that I'm working on so far. I have one controller finished for alpha reviews, and this is a thumbstick controller from an Xbox gamepad. And so it has two potentiometers basically, left and right, forward, back. And it's going through the Arduino, which is processing it with its ADC chip. And it's passing the data into the Raspberry Pi through the I2C connection. Since it's a 10-bit ADC on the Arduino, I have values from 0 to 1023 on each axis. And on the Raspberry Pi, it's taking those data from a Python script and passing it into this pure data patch. You can see the numbers running here. So this is the block that receives the OSC messages coming from the Python script. It gets passed into these frequency blocks that go into oscillators. There are three sort of sources of data that come out of the Python script. One is frequency, which is one axis. One is timbre, which is the other axis, and that changes the balance between the two kinds of oscillators. One's a sine wave, the other's a sawtooth. That goes into the digital to analog converter through the headphone jack. The last is a volume parameter, and that is defined as the distance from this sort of neutral center resting point. So what it allows you to do is go, that's the sawtooth wave, that's the sine wave at approximately the same frequency, and then up and down changes frequency, and then if you head back towards center, it gets quieter and quieter. So even just this simple prototype is pretty expressive, although in the actual instrument there would be about 36 of these, so the sort of frequency range on each one would be much smaller, which would make it a lot more playable. This mapping itself and the synthesis patch are pretty simple. There's a lot of work to be done in the timbre of the instrument and also the sort of data processing. There's a lot more sort of interesting gestures you could get out of the controller. So that's my prototype so far for alpha reviews.